Assalamualaikum. Welcome to SK015. I am Puan Siti Safur binti Zainal Abidin. Let us go to the chapters in this course. There are 7 chapters in Chemistry SK015. Chapter 1, you will learn matter. Chapter 2 is atomic structure. Chapter 3 is periodic table, followed with Chapter 4 is chemical bonding. Next is Chapter 5, which is states of matter. Then Chapter 6, chemical equilibrium. And the last chapter is Chapter 7, which is ionic equilibrium. These are the hours for each chapter. So bring out the total of 18 hours for this semester 1. Let us look at the assessment for this course. 1 is practical test. Practical test will give you 10%. Lab report will be 15%. So these two will be assessed by the lab lecturer in the lab session. How about the assignment? Assignment will give you 15%. Assignment will be assessed by your tutor lecturer. Next is summative assessment test, which is your UPS. What is UPS? Ujian penilaian sumatif. You have ujian penilaian sumatif 1, 2 dan 3. Consists of 20 objective question, which you have to answer within the duration of 1 hour only. Okay, will give you 20%. Next is PSPM1, which is peperiksaan semester program matrikulasi 1. So this is your final exam. Final exam is 40%, so bring out the total of 100%. Okay, let us start with chapter 1, which is matter. Matter got 3 subchapters, which are atoms and molecules for 1.1. 1.2 is mole concept. 1.3 is stoichiometry. Let us start with 1.1 first. Please read the objectives on your own. Matter. What is matter? Matter can be classified into 2 categories. Matter is anything that has mass and occupies space. What is pure substance? Pure substance contain all atoms or molecules are of the same kind. So the keyword here is the word same kind, okay? And it can be classified into elements and compounds. What is element? Element is the pure substance that consists of only one type of atom. One type of atom, and it cannot be broken down into any simpler substances. In the other word, element is the simplest substance. Tak boleh dipecahkan kepada yang lebih kecil. Atom, Okay, for instance, we have sodium atoms, neon, argon, and so on. Done of the monoatom. How about the molecule? Molecule, if you have more than one atom, such as O2, Cl2, F2, chlorine 2 molecule, fluorine molecule, S8, and so on. How about compound? So what is compound? Compound is the pure substance that contains 2 or more types of atoms of elements that are chemically bonded together in fixed proportion. Such as this, we have CO2, carbon dioxide. So, is carbon dioxide is the element or compound? It is a compound. Why CO2 is a compound? Because CO2 consists of 1 carbon atom combined with 2 oxygen atoms. Next is ion. Okay, so compound can be in the form of molecule or can be in the form of ions, such as sodium chloride compound consists of sodium plus sodium positive ion with chloride ion. Okay, next is mixtures. So what is mixtures? It is 2 or more pure substances physically combined, which each retain its chemical identity. All the molecules are not of the same kind. So it is classified into homogeneous and heterogeneous. Okay, so what is the difference between homogeneous and heterogeneous? What is homogeneous? Homogeneous denotes a process involving substances in the same phase. So, if let's say you have one container contain N2 gas, Cl2 gas, O2 gas, so they all mix up together to form the mixture of gases. So they are all in gas phase. Okay, N2 gas plus Cl2 gas plus O2 gas. So denoting a process involving the same phase. How about heterogeneous? Heterogeneous is the other way around, which it denotes a process involving substances in different phase. Okay. Then next. Okay, this is what I did mention before, the definition for matter, anything that has mass and occupies space. And it is made up from tiny unit called atoms. Okay. Then the pure substance just now. So what is element? Is a pure substance consists of one type of atom. It cannot be decomposed or cannot be broken down into any simpler substance. How about compound? Is pure substance, still under category of pure substance that contain two or more elements that are chemically bonded together in fixed proportion, such as ammonia gas and H3 ammonia. Or it can be in the form of ions such as sodium chloride. Okay. Next, what are atoms, molecules, and ions? So atom is the smallest particle of any elements that retains the chemical nature of the element. Molecule is a group of two or more atoms of the same or different types which are chemically bonded, such as of CO2 molecule. How about ion? Is a positively charged or negatively charged particles, which it form when a neutral atom, such as magnesium atom here, when the magnesium neutral atom lost 2 electrons, it will form magnesium 2 plus ion. So it will form positively charged ion. Okay, so different elements will have a different size of atoms. Magnesium will be bigger than carbon. Can you spot the difference between atom and molecule now? Atom contain 3 subatomic particles, which are proton, electron, and neutron. While molecule contain more than one atom. So we have, for instance, water molecule. So water molecule contain 2 hydrogen atoms with 1 oxygen atoms. Next, molecule can be diatomic molecules, which contain only 2 atoms, such as H2 gas, N2 gas, O2 gas, and so on. Okay. While polyatomic molecules is when you have more than 2 atoms. Examples here are ozone, water, ammonia, and methane gas. How about cation and anion? So cation is formed when a neutral atom loses electrons, such as this sodium atom lost 1 electron to form sodium plus ion, while anion is formed when a neutral atom gain 1 electron. For this example, we have chlorine atom gain 1 electron to form chloride ion. The points to remember is to write the charge on an ion correctly. So remember that electron only is the species which is mobile. So atom can be lost electron to form cation, which is positively charged. or it will gain electron to form an ion which is negatively charged. So an atom do not lose or gain proton. It has nothing to do with proton. So proton is still remain in the nucleus of an atom. Okay, so an atom is the smallest unit of an element, right? Atom consists of 3 subatomic particles, which are proton and neutron in the nucleus, while electron will move surrounding the nucleus. These are the mass, the charge, and the charge unit of each of subatomic particles in an atom. So here we can see electron has the lowest mass in gram. It is negative 28 instead of proton and neutron. Neutron is neutral, while proton, the charge unit is +1, electron is -1. So this is the charge in coulomb. Okay, let us proceed with isotopes. What is isotopes? Isotopes is 2 or more atoms of the same element. So the key here must have the same element. Okay, 2 or more atoms of the same element that have the same number of proton, such as this carbon, atoms of the same element still, okay, having the same number of proton here, but different number of neutrons. So it will have different nucleon number. Okay, please remember that we don't have such neutron number. Kita tidak ada such term of neutron number. We just have the term of nucleon number only. Okay, proton number? Yes. Proton number? Yes, we have the term proton number, and the proton number is equal to the number of proton. So, nombor proton sama dengan bilangan proton yang terdapat di dalam sesuatu nukleus. For this chlorine, we have chlorine 35 and chlorine 37. So, chlorine has 2 isotopes. What is meant by isotopes again? The 2 or more atoms of chlorine atom. For this example, right, having the same proton number, which is 17, but different number of neutron or different number of nucleon number. Different nucleon number. How can we represent an isotope? So, an isotope can be represented by an isotopic notation. Penulisan isotop. So, what is this X? X is the symbol of the element. A on the top is the nucleon number. Z is the proton number. While this C plus is the charge. How can we get the number of neutron? Is nucleon number minus the number of proton or proton number. Okay, such as this, we have mercury. So, nucleon number of mercury is 202. Proton number given is 80. And the total charge on the ion is 2 positive, given to you. How to get the neutrons? The number of neutrons is A minus Z, means the nucleon minus proton. So, the number of neutron is 122. You can do these examples on your own. Buat sendiri. Okay. What are the other examples of isotopes? We have hydrogen isotope. Ada berapa? Ada 3. Hydrogen, deuterium, tritium. So, what is the difference? Is the nucleon number on the top. Okay. Percent abundance. Berapa banyak yang melimpah? Paling banyak is 1 here. Okay. How about chlorine? How many isotopes we have? Chlorine 35 and chlorine 37. So, 2 chlorine isotopes. The same goes to bromine. Also, 2 isotopes of bromine. Bromine 79 and also bromine 81. So, they have the same number of proton but different number of neutron. Okay, atoms of the same elements, bromine, bromine, still with the same number of proton but different nucleon number. Next is relative atomic mass, which the symbol is Ar. So Ar is a symbol for relative atomic mass. So when you have to calculate Ar, make sure the answer has no unit. Okay, so what is relative atomic mass? It is the ratio of the mass of one atom of the element to 1/12 of the mass of one carbon-12 atom. So kita compare dengan siapa? Dengan mass of one carbon-12 atom. Atomic mass has unit AMU or U. What is AMU? Atomic mass unit. But when you have to compare with the mass of one carbon-12 atom, make sure it has no unit. So relative, perkataan relative, make sure you put no unit. So why was carbon-12 chosen as a standard atom? Because it is most abundant carbon isotope, happening about 98.89 or almost 100. The table of relative atomic masses based on carbon-12 is close to the agreement based on oxygen. Many elements are able to combine with carbon-12. Carbon-12 was already used as a reference standard in mass spectrometer. Nanti kita akan tengok what is mass spectrometer, and it's also can be handled easily as it exists as a solid at room temperature. Next is the relative molecular mass. The same goes. Still, you have to compare with 1/12 of the mass of one carbon-12 atom. And also, it has no unit. What is the symbol? It is Mr. The relative molecular mass, the symbol is Mr. Okay, so what is the term when you have an ionic compound such as sodium chloride, magnesium oxide, potassium carbonate? The term will be relative formula mass. Relative formula mass. So let us look at the example which you have to calculate the relative formula mass for ammonium chloride. So what to do is to consider the relative atomic mass for each of the atom present in that ammonium chloride. So in this ammonium chloride, we have nitrogen, hydrogen, and chlorine. So you have to consider the relative atomic mass of nitrogen, relative atomic mass of hydrogen, as well as the chlorine. Why we have 2 times 4? Because we have these 4 hydrogen atom. Okay. Then you solve the mathematics and you have the answer is 53.55. Okay, in the last lesson, we did learn about isotopes, right? Okay, what device actually we use to detect isotopes? In the table of atomic mass or in a periodic table, the value of relative atomic mass for magnesium is listed as 24.3. And for chlorine is 35.45. Have you ever wondered where do these values come from? Okay, let us proceed with next term, which is average atomic mass. We have done relative atomic mass, relative molecular mass, and now is the average atomic mass, which it depends on the abundance, which is M, okay, of each isotope, kelimpahan. So the abundance of each isotope is shown as peak in the mass spectrum, which is obtained from a mass spectrometer. So what is mass spectrometry? Mass spectrometry is a technique which we use to determine the relative atomic mass. Kita guna teknik mass spectrometry untuk tentukan relative atomic mass, berat setiap satu isotop, and also the relative abundance of each isotope. Berapa banyak dia melimpah. So different atoms or isotopes or molecules can be identified by their characteristics pattern. Okay. What is spectrometer? Mass spectrometer is one device which we use to determine the relative atomic mass the relative molecular mass, the types of isotopes. So, nak tentukan berapa banyak isotopes. Let's say for chlorine tadi ada 2, untuk bromine tadi ada 2, untuk hydrogen tadi ada 3. So, how many types of isotopes do we have for an element? The abundance, berapa banyak dia melimpah, and its relative isotopic mass, dan berapa berat, berapa the mass for isotope. Okay. An example here, we have the mass spectrum for magnesium. Since we have 3 peaks, ada 3 puncak, we inject the sample of magnesium in that mass spectrometer. Once we inject the sample of magnesium in the mass spectrometer, we have 3 peaks. Kita ada 3 puncak, which then we know that magnesium got 3 isotopes. Ada 3 isotop magnesium, magnesium 24, magnesium 25, and magnesium 26. So, yang mana yang paling banyak melimpah is magnesium 24, which is 63. Then, magnesium 25 is only 8.1, while magnesium 26 is 9.1. The height of each line is directly proportional to the abundance of each isotope. So here, since magnesium 24 has the highest peak, so di sinilah kita tahu magnesium 24 is the most abundant. My question is, which of this magnesium yang kita ambil to put in the periodic table? Ini, nilai 24.31 ini kita nak ambil from magnesium 24, from magnesium 25, or from magnesium 26. Nak ambil daripada magnesium yang mana satu? The most abundant? Nak ambil yang ni ke? Tak. We have to consider the average. Kita kena adil lah. Kena ambil average. Okay. Sebelum kita letak nilai ke dalam periodic table, we have to use this formula of average atomic mass. Do we have the symbol for average atomic mass? No, kita tidak ada simbol untuk average atomic mass. So, what to do is to write it complete, the word by word average atomic mass, tulis penuh. Which average atomic mass equals to sum of Qi times Mi divided by sum of Qi. So, what is Qi? Qi is the relative abundance or percent abundance. Some reference will state for you relative abundance atau percent abundance. Berapa banyak dia melimpah of an isotope of the element. While M is the mass of the isotope. Okay? So, what is I? I is of course isotope. Let us look at the example. Example 1, you are given a mass spectrum. So, this is what we call a mass spectrum. Mass spectrum kena ada apa? Kena ada y-axis, relative abundance. Okay, so relative abundance or the percent abundance is at the y-axis. While at x-axis kena ada apa? X-axis kena ada mass of the isotope. So, how many isotopes do we have for magnesium just now is 3. Magnesium 24, 25, and 26. So, each of the isotope got different peak. Okay? So, how to determine the average atomic mass of magnesium? Ada simbol tak? Average atomic mass? No. No symbol, so you have to write it complete. Average atomic mass of magnesium equals to sum of QIMI divided by QI. Okay, kimi per ki. So, 24 times 63. 24 times 63. Okay, mass yang mana satu? Mass yang dekat x-axis. Okay, Q is the percent abundance or relative abundance is from your y-axis. divide by the total of the percent abundance ataupun relative abundance. So 63 plus 9.1 plus 8.1, the total. So the answer, you calculate, the answer will be 24.33. Put the unit U or AMU. Again, what is AMU? Atomic mass unit. You can use either U or AMU. But the question is asking you to determine the relative atomic mass. What is the next step? Next step is to compare with mass of 1 per 12 times mass of 1 carbon-12 atom. So you carry forward this 23.33U divided by 1 per 12 times 12U of the carbon-12. Cancel U, cancel 12. So the answer, the final is 24.33 without any unit. So remember, relative atomic mass has no unit. Okay, how about the marks? 1 mark will be at the formula. The insert values all correct, 1 mark. U or AMU, the answer. Then next is you compare with carbon-12. The final answer, put no unit, 1 mark. So you have total of 5 marks for this question. Once you have done the average, then only we will put the value of this 24.31. Example 2. Let us look at example 2. The mass spectrum of rubidium is shown below. Based on the mass spectrum, write the isotopes for rubidium. So since we have 85, the mass, and also 87, so how can we represent the isotope? Is this way. How can we get the proton number? From the front page, from the table of the list of relative atomic mass. You have the proton number kan, so you tulis di sini lah. Okay, it will be given in exam. Okay, then 85 is the nucleon number, 87 is the nucleon number, or the mass of isotope. So the mass of isotope sama lah dengan nucleon number. Okay, how to calculate the percent abundance of each isotope? Okay, percent abundance, 18 is the relative abundance. 18 divided by 25 is the total. 18 plus 7. This 18 plus 7. Okay, the total is 25. Then you can, of course, to determine the abundance of rubidium 85. While for the other rubidium, 100 minus 72. So you have 28%. Same goes to this example 2. Okay, let us go to example 4. Example 4 is to lead you to answer question tutorial number 9. So make sure you understand this example 4. Then only you can do question number 9, soalan from your tutor. Okay, relative isotopic mass. Diberi berat isotop of lithium 6. Ni 6 ni ya. 6 kat bawah. Okay, so lithium 6 and lithium 7 are 6.01 and 7.02. What are this? Ini apa ni? Q or M? Berat. Mass kan? Berat. So, kalau mass, the symbol is M. Okay, mass of the isotope means this M. Okay, you have to calculate the percent abundance for each isotope. If the relative atomic mass is given 6.94. Okay, so the value of 6.94 sama lah macam value average atomic mass. Right, but what is the difference between relative atomic mass with average atomic mass? Relative atomic mass has no unit. Average atomic mass, yes, has unit U. Right, so next. Since you have to determine the percent abundance, maknanya you kena cari apa ni? You kena cari Q. Right, you have to find this Q. Let percent abundance of one isotope is X. Mana-mana lah. Lithium 6 boleh or lithium 7 pun boleh. So, the other isotope of lithium, lithium 7, must be 100 minus X. Because the total of these two will be equals to 100%, the abundance, right? So, average atomic mass, the value given is 6.94. You insert it here. Okay, then you masukkan dalam sebutan X. M is given in the question. The mass of each isotope is given in the question. 6.01 and 7.02. The mass, right? And what is this X? This is the abundance yang kita nak cari dalam sebutan X. 100 ni daripada mana? The total of Q. Kan? Ataupun saya prefer you buat this way. X plus 100 minus X. Then X minus X. Tunjuklah sikit the mathematics solving step itu kan. Before you straight away letak nilai 100 kat bawah. Okay. Then you solve your maths. And what is your X? The value of X. Then you can calculate for the other percent abundance of the other isotope. Okay. Then these are the chemical formula of some common cation and anion, which I think you should memorize. Okay, the chemical formula of cation as well as the for anions. That's all for 1.1. Okay, we will continue with 1.2. Thank you.